Hello and welcome to the BMS course. In this chapter we are going to cover the BMS control application for air handling units, specifically the fresh air type, and the training level is basic. The main goal is to understand how to design the BMS system for air handling unit, AHU. The output will be IO table, input output table, and the list of material. By the way, my name is Amir, I'm a mechanics tutor and I'm a BMS expert. I hope I provide you the nice training. Please let me know your feedback. Okay, let's start. As you see, this is a schematic figure of the air handling unit fresh air type. In the design phase, we should figure it out about the IO table and also the list of material. List of material includes the sensor, actuators, drive, valves, and so on. Okay, so start with the beginning. As you see in the picture, for hot coil and cold coil, we have the immersion temperature sensor to monitor the temperature of the hot water and cold water. This information provided as a 4 to 20 milliamp or 0 to 10 volt or passive, and we need the analog output from the BMS side to receive the data. The next one is outdoor temperature. So why we need outdoor temperature? For example, the outdoor temperature is quite good, not so hot, not so cold, and we can open 100% damper actuator and inlet all the fresh air into the building. So we need to read the outdoor temperature. This is something provided as an analog input for the BMS, similar to immersion temperature sensor. The next one is a duct temperature sensor. You can see in the picture this temperature shows what is the exact temperature for the supply air to the room. We need it, especially for closed loop controller for the fan. So we have some set point. The system in closed loop controller is going to control the fan, for example, between 0 to 100% gradually, and open or close the cold or hot coil to provide the adequate supply air temperature for the rooms. So this is one of the key sensors we need it. Also, the temperature sensor is going to provided with the analog input. The next one is AF in the picture. It's antifreeze. For example, we are in a winter and the outdoor temperature suddenly drop. To prevent the freezing, when the antifreeze switch is detect the a bad situation, it's going to close the damper actuator at the inlet and then also switch off the fan to protect the coil. This information is provided as a digital input to the BMS because it's the switch sensor, so the output is 0 or 1. Okay, great. The next one is damper actuator at the inlet. So this damper actuator at the inlet, it provides to control how much fresh air we need it, and it's going to be used as a saving energy. So in this example is going to be connected to the digital output. Of course, it can be used as an analog output to control it gradually. It depends on the project. The next one is analog output to control the valve of the hot coil and the valve of the cold coil. So it's going to help to save energy. If we need 100% for example, hot water, it's going to open 100%, is going to fully go inside of the coil in winter, but maybe in some cases outside temperature is not so drop, so minus. We need it less, and we can control the valve to save energy and provide the adequate output according to the closed loop controller. So these valves, the continuous valves, because it's going to control between 0 to 100%, it's going to be controlled by BMS from the analog output, some signal between 0 to 10 volt. Also, for controlling the fan, if the fan is going to be controlled by the inverter, we need the analog output to send the current between 0 to 10 volt from analog output BMS to control the fan. Also, we have the DPT. You can see in the picture on the right hand side, this is differential pressure transmitter. Some feedback information before and after the fan. It's going to provide us exactly the gradually differences in the pressure. So this is a differential pressure transmitter. It's going to be provided by the BMS in analog input. And the next one is to monitor the filter at the inlet of the air handling unit. So maybe the filter after some time it's going to be dirty, so the pressure before and after is dropped dramatically, so we need the differential pressure switch to provide us some information as a digital input to the BMS, and in this case we can change the filter or wash it. In electrical panel we can see the status if it is manually controlled, or we can see if the status of the motor of the fan, if it's on or off. The next one is provide us the trip or error in the motor or the protection of the motor. So if it's activated, we can see the trip status. The next one is okay, the motor control in manual or automatic. If it's in automatic, it's going to be automatically controlled by the BMS, so the AS is activated. And the most important is with the digital output from the BMS side, we can switch off and on the motor. That's great. So you get some insight into the air handling unit. Now I want to talk more about the different sensor. We already covered it. Okay, temperature sensor. You remember we use the immersion temperature sensor for the cold coil and hot coil. The important things is how you place it. Always you should go to the datasheet. You can see about the direction of the installation. Also, it is important about the wiring. Is this temperature sensor is a passive resistive type, or is it active and the output is 4 to 20 milliamp or 0 to 10 volt? Do we need to provide the extra power supply and so on? So this is important. Okay. So the next one is duct temperature sensor. You remember the supply air to the rooms. We use the duct temperature sensors. It is important about the wiring. For example, in 0 to 10 volt, in this special duct temperature sensors, we should provide the power supply between 15 to 35 volt DC, and the output is between 0 to 10 volt. It is provided the data as an active. Okay, so this is important. Is it the active data or passive data? According to that, we choose the BMS analog input output. Also, it is important about the placement of the duct temperature sensors, how you place it. You can see the placement of the duct temperature sensor in the picture from the datasheet. Always check the datasheet. About the antifreeze sensors, it provides us the contact most of the time. It closes the contact in case of freezing. Also it is important that the probe of the antifreeze sensors can detect all of the coil area. You can see in the picture how you should spread it up. The next one is valve actuator. You remember we have the actuator for the valve in cold coil and cool coil. So the actuator should be defined how many Newton meter we needed for the valve actuator according to the valve base, and also about the wiring. Is it a 0 to 10, 0 to 100% gradually controlled actuator for the valve, or on and off valve? Is it with a spring return or not? So this is important to choose the valve actuator. So this is a base for the valve. Is it a 3-way or 2-way? In the picture of the schematic of the air handling unit, it was a 3-way valve. You can see it is important to placement in the real project, how you place it, the 3-way valve. And yeah, you should take care of it. The drive is suitable to the basement of the valve, and sometimes it needs the adapter to make it work. The next one, we talk about the damper actuator. So in the damper actuator, to let the fresh air inlet to the air handling unit or not. So we should select the right damper actuator according to the which Newton meter we needed, and also about the wiring and placement. It is important. You remember we need to read the outdoor outdoor temperature sensors. We should go to the data sheets, and also about the placement of the outdoor sensor, how you place it. It is important to read the temperature. Sometimes we can use the outdoor sensor to read the temperature plus humidity of the outside. Sometimes we can also read the other data like carbon dioxide and so on. You remember before and after the filter we need the differential pressure switch. So we should select the right differential pressure switch range. Okay, it's different according to the picture from the data sheet. You can see how many Pascal or how many bar before and after it should supply. And also about the placement, you should go to the data sheet to take care of the placement of the differential pressure switch. The next sensor we talk about it is differential pressure transmitter before and after the fan with the inverter. So we want to get the right feedback, how much before and after the gradually fan is provide us the differential pressure exactly. The output is between 0 to 10 volt or 4 to 20 milliamp and provide us precise feedback of the fan working. So let's place it one more time. You remember we have two emergent temperature sensors for the coils. We have outdoor temperature sensors. We have emergent temperature sensor for duct, so duct temperature sensors for supply air. We have antifreeze switch sensors. We have the differential pressure switch for the filter monitoring. We have the differential pressure transmitter to monitor the fan. We have two valve drive to control the coils valve. We have the damper actuator to let in the fresh air or not, or gradually control it. And also we have the control and monitor the electrical panel. All of them are connected to the BMS hardware. You can see in the picture. So the output of the I/O is something like this. Here, according to the fresh air, we need 5 analog input, 6 digital input, 3 analog output, and 2 digital output. So we should provide it here. Most of the time we need the primary controller plus the card for digital input output and analog input output. Okay, sometimes also it is possible for us to select a compact controller. In compact controller, the primary controller and digital input output is coming in one device. Okay, so in the picture you can see the Space Logic Edge Server ASB from the Schneider. Also we can, so this type of hardware is a compact one. The primary controller and digital input output is coming in one device. Also it is possible to use the separated automation server in a Schneider and use the card next to it. So this control is based on BACnet over IP in a BMS. So you can see according to the analog input, digital input, analog output, and digital output, we are going to select the specific model that provides all of these needs. Okay, so there is some needs in I/O, and then according to the I/O we are going to select the right hardware. Also we can use the Synco 900 from Siemens to select it. So here also we can use RMU for the air handling unit, and next to it the digital input output if we need more. Okay, let's talk about some principle about the air handling unit. You can see air handling unit includes different parts like fresh air intake, filter, coils, fan, and output to the rooms. To understand the air handling unit, you should know about the fundamental of HVAC systems. You should know about the heating, cooling points, evaporation process, superheating, melting process, condensation process. You should understand the fundamentals. This is obligation for you to know about it. But you can see here in the picture, I provide you the full fresh air handling unit function. 100% fresh air. It works on the basis of outdoor air. The air taken from outside is conditioned by the air handling unit and blown into the room. There is no heat recovery or mixing in this air handling unit. So there is no recovery. Of course we have the coils for cold, make it cold or make it warm, but there is no recovery in fresh air, 100% fresh air. It is preferred in the case, you can see here, the air is inlet and outlet. We have the cooling coil and heating coil. 100% fresh air handling units, it is preferred in cases where the exhaust air is evacuated with an independent system in case of heat load in the environment due to different reasons, or in the places where positive pressure is desired. So sometimes we need the positive pressure, sometimes we need the fresh air. It according to the mechanical needs. But we as an automation engineer, we should provide I/O, needed devices, make the list of material, install program, and that's done. So units are usually found within the following types of building: industrial, commercial, hotel, hospital, data center, larger houses, and it's installed on the roof or in large plant rooms, or in some special rooms that is provided for air handling unit in a project. Thank you very much to listening to listen to this course. Once again, I hope you enjoyed the course. If you have any questions, please let me know by the email, and I'm happy to help you. And let me know about your project. Thank you very much. Have a nice day and bye.